So these three problems come from Graphing Word Problems Worksheet 8. And number 1, a boat in distress launches a flare straight up with a velocity of 190 feet per second. The height of the flare in feet is given by this equation. So we're going to change it into y equals 190 x minus 16x squared. And here, y is going to represent the h of t, so y is going to be the height, and x, since they mentioned feet per second, is going to be the time in seconds. So what we're going to do is we're going to enter this into our calculator, look at the table to come up with an appropriate viewing window. Now I entered my equation into my calculator and I went to the table, and I went up by 2's just to kind of show you that it looks like x is the time in seconds, y is the height, and it looks like by the time you get to about 12 seconds, the height is negative, meaning it's really underwater, because what's happening is this flare is being shot up to alert a plane, and then it's hitting the ocean and then fizzling out and then going underneath the water. So all the action takes place up to about 12 seconds. And one question here is that they tell you the velocity is in 190 feet per second. And a lot of times students read this and say, well, I guess I have to now plug 190 back in. And the answer is no. Basically, they're just showing you where the equation came from. So when you do these questions, I suggest you write out your equation, try to identify what x and y represent, and then come up with an appropriate viewing window based on your table of values. So here you see that I decided to go from 0 to 12 for my x min and x max. And I went from 0 to about 600 because the biggest number that I saw in the y column was about 564. Now that doesn't mean 564 is the absolute maximum. Maybe the maximum occurred at 5 seconds or something, and 5 is not on my table. I'm just trying to get a ballpark as far as what would be a good viewing window to see what it is we need to see. Now, question A, what is the maximum height of the flare? So in order to calculate that, I'm going to go to second trace for calculate and down to option 4 for maximum. Gave my calculator a left bound and a right bound, and here the maximum height, remember here the height is y, so here the maximum height of the flare is going to be 564.0625 feet. So that's the maximum height that this flare reaches into the sky. B, how many seconds after the flare was shot was it at its maximum height? Well, in this case, that would be the x value, because x is the time in seconds. So it reached its maximum height at 5.93749, I think that's at 97 seconds. If the directions tell you what to round to, you do that. If not, we just write all of our decimals and we just kind of move on. Part C, ignoring the height of the boat, how many seconds will it take for the flare to hit the water? So really, what are you being asked to calculate here? Well, how many seconds will it take for the flare to hit the water? Here's my graph. The water is basically the x-axis. So this particular question is asking, how many seconds will it take for the flare to be shot from the boat? It says ignoring the height of the boat. We're going to assume that the height of the boat is down at this origin here. Flare is shot up in the air. We want to try to figure out this particular point when the flare hits the water. What is that point? Well, that's a 0 of the equation. That's an x-intercept of the equation. Now this one here says how many seconds, and since x stands for seconds, we're just going to calculate the 0 and give the x value. So here the 0 of the function turns out to be 11.875. So after 11.875 seconds, the flare is into the water and has been distinguished. Problem 2 deals with a NASA aircraft, and it's flying in a parabolic arc, meaning it's just a parabola, to simulate weightlessness. So what's happening is the aircraft is taking off, reaching a high point, and then once it reaches its high point, the engines are shut off, the plane kind of drops, and then it kind of continues once the plane's engine gets turned back on. Now you'll see more about why it's shut off and put back on in the second part of this question. But here the question says, for letter A, what is the maximum height? So before we can accomplish that, we need to try to graph this equation into our calculator. And again, enter the equation very, very carefully because it has a whole bunch of decimals here. It looks like y, once again, is going to stand for the height. And then x is going to stand for the t, which is the which is the time in seconds. So the time in seconds. So let's try to enter the equation into our calculator, look at the table, and come up with an appropriate viewing window. So here what I did was, based on my table, I went from 0 to about 100 seconds and for my x's, and I went from 0 to about 40,000 for my y's. I looked at my table and I saw that the numbers in the y column got quite large. And that kind of makes sense. I mean, NASA is flying this aircraft up in the air, so they're not going to be going about 10 feet up in the air. And it looked like the biggest number I saw was in that 40,000 mark, so that's the viewing window that I chose to use. Now to calculate the maximum height, again, I'm going to go to second calculate and option 4 for maximum. And it looks like here the maximum turned out to be 32.5 seconds and 34,000 feet. So in this case, what is the maximum height? Maximum height, 34,000. Now, this second part, it's basically saying that this airplane is taking off, and then at a certain point, they're shutting the engines off. So the plane's still going to be moving, but it's going to be moving then downwards. And it said basically from this high point, they're going to test 45 seconds of weightlessness. So from this high point, 45 seconds after that high point is when the weightlessness test takes place. And your question is, how high is the airplane? So basically, what is the height 45 seconds after this high point occurs? So what you're going to have to do is you're going to have to find a y value. You're going to have to find the height, but what is the x value going to be? Well, the x value, the time in seconds, you would think is going to be 45 seconds. But here's what has to happen. The maximum occurs after 32.5 seconds. So basically this x value up to that maximum is 32.5. Then after 32.5, that's when the 45-second weightlessness test takes place. So you're basically finding the x value at 32.5 plus 45, or you're finding x is equal to 77.5. This question is saying, in its own special way, when x is 77.5, what is y? What is the height of the plane 77.5 seconds into the flight? So you can either go into your table of values and start your table at 77.5, or you can go to second calculate and option 1 is value, type in x is 77.5, and here is y. Here's the height of the airplane, 15,592.75. So there's another example of using a quadratic word problem, quadratic equation, to model an everyday life scenario. Number 3, the height of a punted football can be modeled by this equation. So here we have another quadratic equation, and you're given a little picture here to represent the path of the football. And again, the first question is going to be to calculate the maximum height. We want to find the high point of this football. X represents the seconds, so the time. Y represents the height. So let's first go to our table to come up with an appropriate viewing window for this football. So here's the viewing window which I decided to use. I saw that after 5 seconds the height of the football became negative, so I went from 0 to 5 for my x's, and then the highest value of y I saw is 21.4, so I went up to 40 just to kind of play it safe. So here the maximum height, we're going to go to second calculate and option 4 for maximum. So here the maximum, according to my calculator, occurred at about 2 seconds after the punt, and here the maximum height is going to be about 21.4 feet. So there's our maximum height. So the second part now says, at what time in its flight is the football 5 meters off the ground? So I'm going to use this picture that was given to you, and they want to know at what time in its flight is the football 5 meters up. So if I can draw an imaginary line 5 feet up from the ground, so here's my ground value, and I went 5 meters up. Well, if you notice, there's actually going to be 2 times that the ball is 5 meters up. It's going to go 5 meters on its upward path. There'll be a time, kind of shortly probably into the kick, and then way as it's about to land, there's going to be a time when it's 5 meters up. So here basically we have to go about finding 2 x values 2 times when the y value is 5. So the best way to go about doing these questions is to actually create a second equation just saying y is equal to 5. So I'm going to keep y1 as the original equation, and now I'm going to create a y2 just when y is equal to 5, and I'm going to find the points of intersection of those 2 equations. And the answers to this question are going to be the x values for the points of intersection, because they want to know at what time into its flight is it 5 meters off the ground, and at what time is going to be our x values. So it looks like here, at about 0.2 seconds into the kick, and at about if they ask you to round to the nearest tenth, 3.9 seconds into the kick, the ball is going to be 5 meters off the ground. So that's why that particular question had 2 answers.